Hello, welcome to this lab this Sunday. I'm going to be going over some problems from chapter 6. Let me bring up the assignments right now. Let's see, one of the first problems was let me bring it in 1 second. Here it is. Number 2 was to write an application that counts by threes from 3 to 300 inclusive, and that starts a new line after each multiple of 30 and so on. All right, so let's do A first. I've already done this program, so I'll just bring it up in order to save some time. Here's the program, I'll go over it, and you see the output as well. Oh, you don't see the output. Let me share my screen. Okay, here's my screen. And here is, let me just bring back the assignment so you could actually see it. It's over here. All right, so it's a for loop along with a conditional statement. I've created a few constants here. One we have start is 3, stop is 300, and the numbers per line is 30. So this is easily, I could easily change them if I wanted to. We have a for loop for integer I equaling start, so whatever start is, as long as I is less than stop, so which is our max, and notice the equal to here, so less than or equal to stop. I is equal to I plus equals start, so it's going to increment each time by 3. What are we going to do? We're going to do a system out, the actual value of I itself, plus a space. You could also put a tab in, I guess, to make it a little bit neater. Let's try that. Let's put a tab in. It might go to the left of the screen, but that's okay. And in order to get to the next line, we want to, instead of doing just a print, we will do a print line. So if the number mod, the number per line, so we're keeping track of the numbers, is equal to 0, then we're going to go and do a print line. Let's make sure this works. Going to run it. And we see here the numbers nice and neatly put in there. Great. The next one, hold on one moment. The next problem, or the continuation of the next one, it would be to modify the count by threes application so that the user enters the value to count by. Okay, so I've actually already loaded that up as well in order to save time. It's very similar to the previous one we just did. I'm assuming you could see my screen still. Here we have, we're initializing it at the very beginning as with a stop of 200, and where we have the integer numbers per line as well. I'm also making sure to add at the very top, we're going to import the scanner because we're going to be getting input from the user. And we're going to set it to we're going to set scanner keyboard, so we're going to get the input from the keyboard. Eventually, we'll learn how to get input from other locations as well. We have an integer called a step value because that's how much we want to go increase by each time. And we do a system out, enter the number to count by. Little arrows here indicate that the user is supposed to put in some information. We're going to use our next int to get the integer value from the keyboard into step value. We'll learn eventually as well how to make sure to check for errors in case the user doesn't put in, let's say, an actual number. They put in a word. We'll see how to check for that so the program doesn't crash on us. Then we have numbers per line, which is an integer, is equal to the step value times equal 10. So we get for the first time. And we have for I equaling 0, I equaling step value, whatever the step value is, as long as I is less than or equal to stop. So as long as it's not greater than or equal to, well, not greater than the stop value, which is going to be 200, we're going to increase the value by the step value, and we're just going to print the number up. Again, we'll put some tabs in, make it a little neater. And if I, the same way as before, if I mod the number per line is equal to 0, then we're going to go and skip a line. So let's try this out. Let's do by, I don't know, let's do by 5s. Let's do by 5, enter. And we see here that it's going to nice and neatly count by 5s. And that would work with any number that we want to put in. Let's try another number. Let's try, I don't know, count by 17s. Well, that wasn't very exciting because it gets to 200 pretty fast. We could always change this number at top. We could also prompt ahead of time what value do you want to stop at, because now this is a variable. We could easily go in and modify that. So that's the end of that problem. The next problem we'll do is number 3, run an application that asks the user to type an even number or the sentinel value 999, which means that that's the number that will make the program stop. When the user types an even number, display the message, good job, and then ask for another input. When the user types an odd number, display an error message, and then ask the user for another input. When the user types in the sentinel value 999 and the program. All right, so again, I've already written the program, and I'll go through it right now with you. First of all, I'm going to be using the swing, so I'll be getting the input through a message box, a more Windows type program. I like to switch between the two in order to make sure that you know how to do both those methods. Here's my main. I have an integer number. I have a string called 2 strings, entry and message. I have a final integer called quit, which is 999. That will be our sentinel, which will make the program end. Now we're going to start off with a JOption pane, show input dialog. So we're going to make a dialog box that's going to appear on the screen. It's going to say enter an even number or, and we're going to put in the quit value, which is 999, to quit. So it's program's going to start off by saying, we're giving us this message. Let me actually run the program. I could probably switch between the two as it's running. So that might be an easier example to show you. Here it is, right? So this is the message that pops up. While number is not equal to quit. So we're starting off here with a while loop, and as long as the input does not equal that specific number, and when we press OK, the value of OK is going to go into this value of entry. So if the number mod, and over here, we're going to get input from there. We're going to say number is equal to the integer parse int. Parse int is what I was mentioning before, that this is actually, entry is going to be a string value. Here's because it's this type of string. So it's going to be input as a string, and this parse int is going to convert that string into an integer. So if they enter the number, the digits 22, right, it's going to read that as the string 22, but then the string 22 will be converted into an integer with this parse int. While the number is not equal to quit, so as long as it doesn't equal 999, it's going to say if number mod 2 is equal to 0. So if it's divisible by 0, it's going to say good job. Otherwise, it's going to say it's not an even number. Then we're going to show the option pane again. The same way we did over here, we're going to do it again, and we're going to do the parse int, and it's going to do it again and again until they enter the 999. So let's just try this out. Let's enter 34, enter, I'll do OK. It's going to put in, good job, click OK, it's going to do it again. I'm going to put in the number 11, I'm going to click OK, it's not an even number. Click OK, I'm going to end the program by doing 999, click OK, and the program ends. All right, if you have any questions on that one, you can let me know. The next problem, number 4, is write an application that displays a factorial for every integer value from 1 to 10. A factorial of a number is the product of the number multiplied by each of the positive integers lower than it. For example, the factorial of 4 is 4 times 3 times 2 times 1. This is a classic example that when you're learning for loops that almost every textbook has. I've must have given this program, I don't know, 100 times. So let's take a look at how it would look. We have the program is called factorial. We're going to end it. Our final is going to be our constant integer max. This is as high as we're going to go. We have integer factorial for I equaling 1 as long as I is less than max, I plus plus. Notice here we have a for loop inside of a for loop. So our outer for loop is going to be going from 1 to max. And then we have our factorial is equal to I. So this factorial is based off of this outer loop's number. So the first factorial is going to be 1, then it's going to be 2, then it's going to be 3, and so on. Then we're going to do the actual factorial itself. Notice over here that for this for loop, there is a curly brace, which pretty much means there's more than one line. All this code is inside of this for loop. This second for loop here, notice that there's no curly brace. That means it's only only this one line is going to be executed. It's also shown by the by the tab that it's tabbed in, but that doesn't really matter. It doesn't have to be tabbed in, but this one line will be executed each time. So we have for j equaling 1, if for j equaling I, which is going to be 1 the first time minus 1, so it's not going to do it the first time, but for j equaling I minus 1, as long as j is greater than 0, minus minus j. So it's going to take the number and go down by 1 each time in the for loop. What's going to happen? Our factorial, which is equal to the first value, it's going to be equal to the factorial times j. So it's going to multiply it again and again and again, all the way through. And we're going to do system out, print line, the factorial of I is, and it's going to give us our the factorial of it. If we run it, we'll see that we get all the factorials here. There is a limit, though. I mean, integers can only go so high inside of Java. Notice the factorial of 1 is 1, 2 is 2 times 1 is 2, 3 is 3 times 2. 3 times 2 times 1 is 6. We could actually even modify this a bit if we wanted to show the actual numbers that are being that are involved inside of the factorial. If we make it a really high number, we're going to get some, like I said, some strange results. Let's try that actually. Let's change this to 15. Let's see what happens. Change this to 15, and we'll run it. It's still working, I guess. Let's change it to, I don't know, 50. The numbers get awfully high. We're gonna get probably some, yeah. So we get some strange results because what happens is we get higher than the actual value that an integer could have inside of the memory of the compiler. So then it jumps to negative numbers because because of the last bit of the number itself is indicating that it's going to be a negative number. But in any case, you get to negative numbers because we go too high. If you wanted to solve that up to a certain point as well, you can make this a long instead of an integer, the output, and that will be able to go a bit higher because it's opposed to a 16 bits of information as being stored will be 32. But again, there's still a limit to that as well. Anyway, the actual program itself is a for loop instead of a for loop. And like I said, this is a classic example. And if you have any questions on it, please let me know. Number 5, write an application that prompts the user for 2 integers and displays every integer between them. Display a message if there are no integers between the entered values. We're going to call it in between. So here's the program. Over here, again, I've included scanner because I'm going to get input from the user. I'm doing a KB for keyboard. Number 1, number 2, both integers. Diff is going to be the difference. Integer x is going to be, we're going to keep track of utilizing integer x. Enter an integer, it's going to get the first number. It's going to go into num1. Enter another integer, and that's going to go into num2. num1, num2. The difference between them is going to be the num1 minus num2. If the difference, if the second one is greater than the first one, then you can't do it because there's, that's like entering the number, I don't know, 10. Let's just say that it was 10 and 5, right? Well, what's it between 10 and 5? Well, there are, but we're supposed to put the lower number in first, so we can't. So that's what we're checking for over here. So assuming that this is not the case, which is a conditional statement, right? We're going to jump to this else. And also, please notice that this if does not have curly braces after us, so it's only one line of code. Else, and now we're opening up a curly brace, so everything inside of here is the target of the else. The numbers between num1 and num2 include, now we have here, if num1 is greater than num2, then for x equaling num2 plus 1, and as long as x is less than num1, we're going to add 1 to x each time. We're going to print up the number. Else, we're going to do the for num1 plus 1 all the num2. As long as x is less than num2, we're going to add 1 to that. We're going to print up the values of those. Right, I guess I should correct over here. This conditional statement is not checking if it's in reverse order. We will be able to go and check between. This is checking if there's actually no difference between them. Let's run this. Take a look. Enter the first integer. Let's bring this up a bit. Here we'll enter 2. and I'll enter another integer. I'll enter 10, and the numbers between them are 3, 4, 5, 6, 7, 8, 9. And now let's go do the second way. Let's enter the number here. Let's do 15 and 1. Hit enter, and it shows the numbers between them. If there's nothing between them, which is what this conditional statement would do, we get that there is no integers between them. All right, that's the end of that problem. Number 6 deals with a perfect number. We're supposed to write an application that displays every perfect number from 1 through 1,000. So what is a perfect number? A perfect number is one that equals the sum of all the numbers that divide evenly into it. So the easy example is number 6. The number 6, the factors of 6, including 1, is 1, 2, and 3, right? 1 goes into 6, 2 goes into 6, and 3 goes into 6. They're factors of it. If you add those up, 3 plus 2 plus 1 is 6. That's what makes 6 a perfect number. Divide into it, and the sum is 6. 12 is not a perfect number. Why? Because these are the factors of 12, 1, 2, 3, and 4. If you add these up, it does not equal 12. So that's what a perfect number is. So the program for this would look something like this. Let's take a look at it. We have our main. We're going up to 1,000. So for I equaling 2, because we're not going to start with 1, and as long as it's less than max, which is 1,000, I plus plus. If perfect is equal to true. So we have a method here called perfect, and here's perfect. It's going to return either a true or a false. So what's a true or false going to be? Well, we're going to check it out here and see if the number is perfect or not. In order to do that, they're going to be passing in a value. In this case, the first time down, they're going to pass in 2, then they're going to pass in 3, and so on. Sum is equal to 1 inside of our method perfect. Boolean result is equal to false. We're going to assume that the number is not perfect unless we find out that it is. We're going to have for j equaling 2, integer j equaling 2, as long as j is less than or equal to n divided by 2. We're going to go up to half of the numbers because there's not going to be anything with if you want to get a factor of a number, there's no sense in ever going past it. Say, for example, the number, if we're trying to find the factors of 20, right? If we find a factor, we could check 1, we could check 2, well, we could check 2, 3, 4, 5. After 10, right after the number 10, there's not going to 11. There's no way 11 can be a factor of it because it's more than half of it. So that's why we go up to half the number, j plus plus, if n mod j, if the number that was passed in mod j is equal to 0, which pretty much means if the number goes into it evenly, then we're going to change our sum, which is equal to 1, plus equals j. We're going to add it to it. Let's take our 6 as an example, right? 6 was passed. Let's pretend 6 was passed in. So I'm going to say n is equal to 6. All right, so the first time down, our n is equal to 6. Our sum is equal to 1. Let me put over here, I'll say sum. Let's just manually do this first. Okay, sum is equal to 1. Let's pretend. The result is false. For j equaling 2, and let me just set my j up here. Okay, I'm going to say j is equal to 2, okay? As long as j is less than n divided by 2, n is was 6 divided by 2, so as long as it's less than or equal to 3, what's going to happen if the first time down is going to be 2, right? Because that's what it's equal to, is if n, which is, this is actually would look like this, if 6 divided by 6 mod 2, right? What's 6 mod 2? The mod is remainder. So 6 divided by 2 is 3 with a remainder of 0. So this would be true, right? So we're going to add sum is going to plus equals the j, right? The j, which is what we just did. So j is going to, now it's going to be equal to 2 plus 1, it's going to be 3, right? And if the sum is equal to n, result is true. Otherwise, we're still inside of this for loop, right? There's no curly braces here. So we're just going to be doing this line again and again and again. Next time down, it's going to be, j is going to be equal to 3, right? If j is equal to 3, we're going to say if 6 mod 3 is equal to 0, right? Which it is. We're going to do 3 plus 3, which is going to be 6. Next time down, it's going to be, well, we're not going to go past it actually because it's, we're going to jump out of the for loop. Once you jump out of the for loop, at the end, we're going to say if the sum is equal to n, in this case it is, sum is equal to the n that was passed in. Our n was 6 and our sum is 6. Result's going to be true. So we're going to return result, and so it's going to add that to the list of numbers that we're going and we're sending out. So let me run this really fast to show you that it hopefully works. So the first perfect number is 6, then we have 28. Next is 496. I wonder what the next one is. Let's see if we could, let's pop this number up here. Let's add a couple zeros. So the next one after that is 8,128. And we could even, if we wanted to display the numbers, we probably could modify this just a little bit. Let's tweak this a little bit here. If we wanted to, we could put in a curly brace here, and if it's true, we could actually print the number up as well. I'm not going to spend my time doing that, but we could actually show the number that it is, and then it'll add a lot more to this output. All right, good. The next one. All right, the next problem is, let me bring it up. 1 second. Over here, right? Run an application that uses a loop to create a pattern of O's shown in this figure. It's a little bit of a slide here. Again, this is a standard problem that's usually given to show nested for loops. Here's the result, right? We have our character O, we have a space over here. Rows is 10, space is 0, integer A and B. It seems like a lot of variables here. So we have a for loop inside of a for loop. Usually when you have a problem like this, you have a amount of space you want to go in and amount of times you want to do it. The amount is going to be changing. So let's just go through the example for A equaling 0, as long as it's less than rows, A++. So we're going to be going down these rows. First time it's going to do this one, then this one, then this one, and so on. Now for each one of these, we're going to do this. For B equaling 0, as long as B is less than spaces, B++, right? And we're going to print up the spaces. And then at the very end, after we print the spaces, we're going to print up the zeros, and then we're going to do spaces plus plus. So the spaces are going to increase each time we go through it. So let's just run the program. And the output is not showing up. Let me try this again. Stop this. Let me actually, I have a lot of stuff open here. Let me close a lot of these. There it is. So here is how it looks. This is a nested for loop. This for loop is the target of this for loop, and it this is the output. We could obviously change any one of these. We want to make it longer. We have more rows, different character. We put in different character, and it's a nested for loop. The next one is number 10. Write an application that prompts a user for the number of years the user has until retirement and the amount of money the user can save annually. If the user enters 0 or negative number for the value, reprompt the user until the valid entries are made. All right. Assume that no interest is earned on the money. Display the amount of money the user have at the end of retirement. Oh, at retirement. All right. So here is the solution. I'm using scanner here. Never main. Number of years, save amount, and total. How many years until retirement? We're going to get the number of years. We're getting it as an integer. While the years is less than 0, we're going to keep saying years cannot be 0 or negative. Do it again and again. So this will force the user to put in a positive number. How much money are you going to can you save annually? We have the amount that they're able to save, and this is going to continuously go again and again until they put in the proper amount that's going to be it's going to be greater than 0. Finally, after all that, it seems like the main part of the program is just over here, right? We have the total is equal to the save amount times the years. So whatever they're able to save times how many years, that's what the total is going to be. And I'm going to do an output. If you save amount per year, your total is going to be, I'm going to print up the total. That should work. Let me run it just to verify. Let's first I'll put it in -1. Nope, can't be negative. So let's see. I have, let's say, 20 years to retirement, and let's say I'm able to save $15 a year. Yep, that's about right. So $15 a year for 20 years, I'll have $300 for my retirement. Kind of sad, but that's what the answer is. The second part of this is to modify the retirement goal application to display the amount of money the user will have if the user earns 5% interest on the balance each year. So let's take a look how this is going to change. So we have the following. The same amount, the beginning is the same. We're forcing the user to put in a positive value there and a positive value here. The only difference is going to be here at the bottom, right? We have the same amount, we have the amount of years. The same amount is going to be the same amount times the years. Like when I put in the values here, the values in the first one, it was 20 years and $15 a year, right? But we're going to now, though, go and change by figuring out the interest. So we have total 2, it's going to be a double because we're going to be getting some non-integer values and double values. For y equaling 0, as long as y is less than years, the total is going to plus equals save amount. And the total is going to equal the total plus the total times the rate. So this is where we're going to figure out what the interest is going to be. And the rate, I must have passed over that before, the rate is going to be over here, which is going to be 5%. And if we go through that for loop at the very end, when we print out the result, we'll see that it's going to obviously be different. Let me put the same numbers in, 20 and 15. We'll see 20 and 15. So we saw before it was 300, and here if we get 5% interest, it's going to go up to a whopping $520. All right, I'm going to stop the lab right now here. If you have any questions, please let me know. I'll post this to the group, and please let me know if you have any other questions. That's all. Bye.